Chapter 2 is about set theory. What is a set? A set is a collection of objects. Any collection of objects we call a set. And we write set with this notation. This is how we represent a set. And this collection of objects, we separate them by comma. For example, students of this class. So if I write all of your names here, that's a set. A set is a collection of objects. And these objects we call either elements or members. We're going to use both. Sometimes we say elements of a set. Sometimes we say members. So these objects are elements or members of the set. Some examples. Students in this class. Students majoring in STEM. Collection of professors here. Collection of buildings. Anything you can say. It's a set. Any collection of objects is a set. Next thing is sets can be represented in three ways. First is roster form. You can represent a set in roster form. Roster form means you are just writing out everything. You write out the members, putting a comma in between. Write them out. Write the members out. That's a roster form. So there are three ways to represent a set. A roster form. Second is set builder notation. Set builder notation, that means we say the set of all x or something such that, what is x? Then we describe what that x is. We say x is the name of a student. In this class. So that is set builder notation. We put set. How do you read it? Set of all x such that. Then we describe it. This doesn't mean there's only one student. You write all those names, okay? They're just describing what those x are. Set of all x such that x is the name of a student. So if I say set of all x such that, set of all x such that, x is a counting number less than 10. So how do I write this in roster form? I'm going to write all the counting numbers less than 10. What are the counting numbers less than 10? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is roster form. This is set builder notation. Roster means you just write them out. Set builder, we say set of all x such that what that x is. Then the third one is we just say in the words. We don't use that notation. We just say set of all numbers less than 10. So we don't even use set notation there for description. We just write set of all. So description is this. Set of all counting numbers less than 10. Counting numbers less than 10. So this is Set builder notation, this is roster form, this is description. In description, we don't use any notation, set notation. Okay, so those are the three different representations of a set. Set can be in roster form or set builder notation or description in words. Naming sets. We use capital letters to name a set. So I can call this set as set A, set B. We use big letters to represent sets. We name that sets. Set A is that, set B is this. Okay, so we use big letters to name the sets. So set A is the set of all counting numbers less than 10. We use a lot of numbers, so we need to know the definitions of natural numbers, whole numbers. Natural numbers are the counting numbers. 1, 2, 3, 4, 5. If you add 0 to it, we say it's whole numbers. If you add a negative, then we say integers. So that is the set of all counting numbers. The set of all whole numbers, we simply add a 0 to that. These 3 dots, what does that mean? It means it continues, right? It doesn't stop. And there is a name for that, ellipsis. That 3 dots, you put exactly 3 dots to show that it continues. And integers, set of integers, you need 3 dots at the beginning and you need 3 dots at the end because it doesn't have any beginning, doesn't have any end. That's set of integers. Set of natural numbers, set of whole numbers, set of integers. We may use these. So if you're asked to do natural numbers, then just only do 1, 2, 3, 4. Whole numbers, 0 is included. Integers, negatives are also included. Set of counting numbers less than 10. That's that. That is the set of all counting numbers less than 10. Less than 10 means 10 is not included. Less than that, okay? Less than 10, 10 is not included. Greater than 1, that means 1 is not included. If you want to include 1, you can say greater than or equal to 1. If you want to include 10, you can say less than or equal to 10. If you want all numbers from 1 to 10, you can say less than or equal to 10. Express in roster form. Set B is the set of all natural numbers less than or equal to 80. So we write all natural numbers starting from 1 all the way to 80. I didn't want to write the whole thing, so I put those 3 dots in the middle. It's 1 through 80 because it's less than or equal to. Set P is the set of planets in Earth's solar system. There it is. Okay, so 3 ways to represent a set. Roster form, set builder notation, then is description. The next thing is element of. This symbol, E, says it's an element of. That's what it means. It's a member of or element of that symbol, okay, E. So I can say 1 is a member of A, right? Because 1 is an A. 2 is also a member of A. So that's what that symbol means, E symbol. That means member of. It is a member of that set. Yes, 2 is in there. But how about 10? Is 10 there? 10? No. So how do you say that? 10 is not a member of A. That's how you say not a member. You cross it. So 10 is not a member of A. 1 is a member. So 1 is an element, 2 is an element, 3 is an element, but 10 is not. So this means it's not an element of. You have to understand all those symbols, okay? So E is a member of. Crossing it means not a member of. Set builder notation. This is how we write in set builder notation. Set of all x such that, then we say what is this x? X is in set of natural numbers and x is less than 6. Or you can say x is less than or equal to 5. You don't have to say like that. You can say set of all x such that x is a natural number less than 6. You can do that. That's correct too. So any of this is fine, set builder notation. You pick the one, whatever in the choices. Because it's multiple choice. All tests are multiple choice. You can write in any of those 3 forms. You can say less than or equal to 5, or less than 6, or natural number less than 6, less than or equal to 5. Two, 3, 4, 5, 6. So it's between 2 and 8. You can say 2 less than or equal to x less than 8. Or you can say 2 less than or equal to x less than or equal to 7. Or you can say 1 less than x less than 8. These are all correct, as long as x is in set of natural numbers. So first you have to say x is a natural number. That's what we are saying like that. But you can write it out if you want. You don't have to use that symbol. That means x is a natural number and x is in between 1 and 8. Or x is in between 2 and 7, both included. That's why it's less than or equal to, greater than or equal to. Finite set. Finite set means there should be finite number of elements in that set. It's just that word, a finite. As long as you can count, it's finite. 1,000 elements, it's okay, still finite, right? 10,000, fine, it's finite. 1 million, yes. But if you cannot count, then it is infinite. So finite set, infinite set. The number of elements is finite. Finite means you should be able to count how many are there. It could be a very big number, but that's okay. As long as you can count, it is finite. But if you cannot count, it is infinite. Set of all natural numbers, it's infinite. I cannot count it because it goes on. 1, 2, 3, 4. But the number of students on this campus, I can count. Maybe it's a big number, but still I can say how many are there. That's finite. So infinite means the number of elements is infinite. The set of counting numbers is an example of an infinite set. It's infinite. We don't know how many are there. The next is equal sets. When do you say 2 sets are equal? 2 sets are equal means they are equal. They are the same number, same elements, everything same. You know that in a set, order doesn't matter. Okay, you can write this way or you can change the order. It doesn't matter. You can write 3, 2, 1, 4, 5. I mean, any order you can write. Don't repeat elements in a set. And order doesn't matter. So 1, 2, 3, set 1, 2, 3 same as set 2, 1, 3. Or 3, 2, 1. As long as elements are same, numbers are same, then yeah, they are equal. So these 2 sets are equal. Remember, order doesn't matter. Does not matter in set. And you don't repeat, okay? You don't write 1 twice. You don't repeat. Cardinal number. What do you call a cardinal? Cardinal number, you write like this. It is the number of elements. How many are there? So what's the cardinal number of this set? How many are there? 3. Cardinal number is the number. How many are there? That's cardinal number. There are 3 elements there. If the cardinal number of 2 sets are the same, we call those sets equivalent. So equivalent means only the number. How many are there? That should be the same, but the elements can be different. See, these 2 are equivalent. But are they equal? No. If they're equal, they're automatically equivalent too, right? Because equal means everything same. So they are equivalent too. Equivalent means same number, but not same elements. So these 2 sets are equal or equivalent? Equivalent. Because there are 3 elements in set D, there are 3 elements in set E. They are equivalent. So you will get a problem. You get 2 sets. You have to say equal, equivalent, both, or neither. You don't pick equal, right? Because if it's equal, it's already equivalent. So you pick both. Correct? So both, equivalent, or neither.
So anything it's an equal set is going to be equivalent. It's both.
Yes, because obviously, same number, yes.
Mm-hmm.
So it's both. Equal, automatically equivalent, but equivalent doesn't have to be equal. So you don't choose equal at all. You either choose equivalent or both or neither. Understand? Equal, automatically equivalent. See, these are both, but this one is, these 2 are not equal. They are only equivalent. You will you'll see some problems. You have to choose which one, equal, equivalent, both, neither. And you never choose equal, because if it's equal, it's all automatically equivalent. So you should choose both. Null set or empty set. A set with the nothing is called a null set or empty set. No elements in it. That's null set. And the notation for null set is you can do like this or you can do the 5. This is null set. Nothing in here. Or you can do that. Empty set. What is the cardinal number of empty set? Cardinal number is the number of elements in it. What's the cardinal number of an empty set? 0, because there's nothing in there. Cardinal number of an empty set is 0. But if you write a set with empty set in it, then that's an element. Cardinality is 1. Cardinality of empty set is 0. This is cardinality 1 because there is 1 element in there. Although it is 0, but it is an element. If you write a set around the empty set, it's not an empty set anymore because there is an element in there. Okay. Universal set. Universal set is the biggest set you can think of in that situation. If I say my set is the students in this class, then the universal could be the set of students on Dale Maybury campus. So universal set, our set is a subset of that. That's universal set. It depends on what situation we are using. So if you are using counting numbers 1 through 10, then the universal set is set of all counting numbers. So our sets are subsets of that universal. Universal is biggest. So that is 2.1. So terminologies, terms. Okay. So there are 3 forms for a test. So press set builder, roster, description. Then we learned about equal set, equivalent set, cardinal number, empty set, universal set, sub element of, that notation E, element of, not an element of. Okay. Those are the words we studied in this section. So let's see whether we can answer these vocabulary questions. A collection of objects is called a set. Yes. Three dots at the end. What is that called? Ellipsis, right? Yeah. The 3 ways a set can be written are roster form, set builder form, and description. Yes. So roster, set builder, and description. A set that contains no element or the number of elements in a set is a natural number is called a finite set. If we can count them, that's a finite set. If it's not finite, it's called infinite. Infinite set. Finite set, infinite set. 2 sets that contain same elements are called equal. They are equal. Equal sets. 2 sets that contain the same number of elements, they are called equivalent. The number of elements in a set is called the cardinal. Yes, cardinal number. That's what it's called. The set contains no elements is called a null or empty. Yeah, that's what you answered here. It's called null set or empty set. A set that contains all the elements for a specific discussion is called the universal set. Oh, the last one is just a 1-to-1. We don't have to worry about that. 1-to-1 correspondence. Okay, determine if each set is well-defined or not. So a set has to be a well-defined collection of objects. Okay. The set of most interesting courses at your school, that is not well-defined, right? Because it depends on who is taking the course. So you cannot say a specific answer. So it is not well-defined. That is not a well-defined set. The set of 4 states in the United States having largest population, that you can say if you do some research, right? It is well-defined. The set of most interesting teachers, that's no, right? You can't say that. That's not well-defined. So well-defined. That means you should be able to say the elements of that set. And it should be the same, no matter who says it. Okay, so that's well defined. Determine whether each set is finite or infinite. The set of multiples of 4 between 0 and 50.
Finite.
Finite. Right? You can count them. The set of fractions between 1 and 2. That's infinite. We don't know how many fractions are there between 1 and 2. An infinite number of fractions. The set of apple trees. You can count. Maybe it takes some time, but still you can do it, right? So it is finite. Write each set in raster form. Tell me the numbers between 10 and 178. Between means you don't include those. Otherwise, it will say included, okay? If it doesn't say included, don't put those numbers. So start from what? 11, 12. Okay, I'm going to put dot, 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 okay? And then last is 177. Those are the natural numbers between 10 and 178. X plus 6 equals 10. There's only one number there. What is that? That is just 4. Because x plus 6 is 10. X is 4. That's the only number. So the raster form is actually the solution of that equation, which is 4. That is how you write in raster form. Set of all x in n, 14 less than or equal to x less than 85. So you start from 14, then you go all the way to, which one the last one? 80? 84. Yes, 84. Okay, use the table to answer the questions. These are the 10 most visited museums in the world in 2008. Okay. First question. The set of museums in which the attendance was less than 3 million. Which one? Less than 3 million. The last two, right? Yeah. So you may want to write that. Those two museums. Museum of Modern Art and the other one. Those are the ones less than 3 million. The next is set of museums in which attendance was between 3.5 and 5.5. 3.5, so starts from here, right? And 5.5, so stop there. That's good. Yes. So write those. Express in set builder notation. So I'm going to write this as set of all x such that x is an element of natural numbers and x is, you can write less than or equal to 9 or you can write less than 10. Or you can just write natural numbers less than 10. That's fine. Set of all x such that x is a natural number less than 10. See, there are 9 numbers in there. How do I write this? D equals set of all x such that
X is an element of a natural number
mm-hmm.
greater than 4.
But they are multiples, right? So can I write 5x? 5x, right? 5 times 1, 5 times 2, 5 times 3, right? Or maybe I should say 5x then comma x is in n. Or you can write like this, set of all x such that x is a multiple of 5. Multiple of 5. You can write like that, right? 5x, which is multiple of 5, or just write multiple of 5. 15, 16. F equals set of all x such that x is in n, then what? Then you can say 15 less than or equal to x less than or equal to 100. Or you can say 14 less than x less than 101. There are many ways to write it. Or you can just say x is a natural number between 14 and 101. That's fine too. Okay, write a description. Tell me a description of this set. Set of all natural numbers or set of all multiples of 3, correct? Yes? Are they multiples of 3? Yes. And A, E, I, O, U, what is that? Vowels of English alphabet, right? Set of all vowels of English alphabet. Now we have another table. Use this table to answer these questions. Set of all X. X is a country with fewer than 100 million cellular subscribers. 100 million, less than. So, the last two, right? Yes? Pakistan and UK? Am I right? Is that right? Okay. Between 250 and 500. Between 250 and 500. How many?
India and United States.
That's it, right? Yeah. So, state each statement true or false. Okay, take your time. Is that true or false? This one? Yeah, but see the set around it? That makes it false.
Because we can only include E.
Yeah, just E. That you should say. No set. So if there is a set, we call it subset. That's coming next section. So it cannot be a set around it. Just E is fine. But set E is not. Set E, we're going to write as a subset. That's coming next section. Okay, how about second one? That is true. How about the third one? That's false because H is not there. Is Mickey Mouse a character? Yes, right? That's true. 3 is not in that set. Actually, 3 is an odd number, right? So 3 is in that set. So if I say 3 is not, that is false. Is Amazon a river in the United States? I'm not sure. False, okay. I'm not going to put anything like that on the test, okay. I don't know about the next one either. Titanic. Is that true or false? Top 10 motion pictures, the greatest revenue?
I don't think so.
Okay.
Yeah.
Okay. 2 is an odd number. No. 2 is even. So it is false. 2 is even. So it should be like this. 2 is not like that. Then it would have been right. Okay, tell me the cardinal number of A. What is n of A? How many are there? 4. Tell me n of B. Did you count? 6. Okay. What is n of C?
5.
N of C. 0. Okay. N of D? 5. Okay. N is the cardinal number. How many are there? Okay. Determine They are equal, equivalent, both, or neither. Algebra, geometry, trig. Geometry, trig, algebra. They are both. Yes. Both. 7, 9, 10. ABC. Equivalent. Grape, apples, oranges. Grape, peaches, apples, oranges. Neither. They're not equal, they're not equivalent. A is the set of letters in the word bank and post. They are equivalent, 4 letters, but they are not the same. So these are equivalent. A is the set of states, set of capitals. Equivalent. They're not same, right? But one state has one capital, so its number is the same, so equivalent. Okay, that's 2.1. Now what?
Question,
Yeah.
Will you be posting all these notes?
I can do that. Actually, I'm recording it. It will go to our class, okay?